On number 2, and we are continuing, okay? And you have seen that I haven't spent much time at all trying to understand the problem, trying to read all this stuff, okay? I'll come back to any part of it if I am to see a question that would need me to explain and me to find out what's going on. So here, all I've been doing is seeing this graph and trying to answer any question that they want us to answer. Remember, calculation questions, all right? Because I don't want to risk failing to answer a question simply because I did not understand the English. At least we should know the physics part. And for us to know the physics part, we don't have to go through this whole problem, you understand? So for us, it's like we have to read the problem itself here. Determine the distance. So if I have been asked to determine the distance and I go up and I see I have a graph, and this is a speed time graph, right? This is a speed time. I'm going to trust my physics, which tells me that if you have a speed time graph, then the area under the graph is the distance. You understand? Now, physics is what we trust, right? The area under a speed time graph is the distance. Let's talk about the graphs because the graphs are so simple, right? Let me just try to increase the size of our pen and let's talk about the graphs. So I have only 2, right? Okay. We can say we have a distance time graph and then we have a speed time graph, okay? There we go. So speed time graph and velocity time graph, no difference, right? No main difference. So we have distance time graph. On a distance time graph, we need to know that in here, the gradient is the speed. Then on a speed time graph, the gradient can be the speed again. Because it's a speed time graph, now the gradient, which is the slope, will be the acceleration. Okay? But then you should know that on this one, the area is the distance. Okay? The area under the graph will take us to distance. The area under the graph will give us distance. Now you say, what about the area under the distance time graph? It's nothing. It does not tell us anything. So this is all we got to know. Okay, this is all we got to know. If we had it as being a displacement time graph, instead of a distance time graph, okay, displacement time is just the same. If we say we have a displacement time graph, it is just the same. Because on here, we'll say now the gradient, instead of being speed, is now velocity, okay, the vector version of speed. And on a velocity time graph, okay, we say, okay, we have a velocity time graph. Here, the gradient is still acceleration, okay? The gradient is acceleration. But now, the area under this one will now be velocity. Okay, will not be, displacement. It's a velocity time graph. The area will take you back to displacement. You understand? And that's how easy it is. This is how easy it is. It's very easy. You see the graphs? So I know that I have, the moment I see a speed time graph, if I see a speed time graph, I can get what? Acceleration. And what else can I get? I can get the distance. How do I get the distance? Area under the graph. Area under the graph. So they want the distance. The moment they say distance, it's a speed time graph. It's a speed time graph. So distance is the area. Okay, if it was acceleration, it would be the gradient. So distance is the area under the graph. So I'm going to look. They said in the first 6.5 seconds. So I'm going to see 6.5 seconds. You understand? So here, this is 4 and this is 8. So in between them is 6. Now I want to have 6.5. So what would it be? So I would say, okay, if this is 6, let's zoom in, guys. Let's zoom in here. So this would be obviously 4.4, 4.8, 5.2, 5.6, and a 6. Okay, each would be 4. You understand? Because there's 2 between these small things. We have from 4 to 6, so that means 1 should represent 0.4. If you want to find out, you can just say 6 minus 4 over the number of boxes, which is 1, 2, 3, 4, 5, which is over 5, and you should find 0.4. So each box represents 0.4, so it will be 4.4, then 4.8, then 5.2, then 5.6, then 6. So here is a 6.4, so this is a 6.4. We want 6.5, so you go slightly after 6.4 in here, okay? So I'm going to move like this. This is my 6.5. I'm going to follow it all the way up, 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 and I see it goes right to the peak of the mountain. So, okay, no problem. 6.5, you're going to lead me to the peak of the mountain. What value is this peak of the mountain? Okay, it leads me to the peak of the mountain. What value is it? I'm going to move like this here. Okay, here. And it's going to lead me to this place. Now, what value is this? That's the question I ask myself. What value is this? Okay, I can see it's exactly between 120 and 140. So this would be 130. So we have 130. So, okay, no problem. I want the area under this. Okay, and this is what? This is a triangle I can see with height 130, and then the base is 6.5. Okay, here 6.5. So the base is 6.5, and I have height, and the height is 130. So I know distance. So I'm going to come down and say, okay, here I'm going to say distance. Distance is equal to the area of that triangle, which is base times height over 2. That's the area of a triangle. And what is my base? My base is 6.5. So it's going to be 6.5. And what is that? 6.5 seconds, right? Times my height. Don't forget the units. Don't forget the units. My height is 130 and its speed, so it'll be 130 meters per second. Do not forget the units. You're in physics, okay? And it's all over 2 now. So let's put it in the calculator. Let's see what it gives us now. Okay, I hope you're enjoying. So now let's see. Now I'm going to put this. I would say, all right, 6.5. And I say times 130. Then I say divided by 2. I'm going to get 422.5. Okay, so I have 422.5 and it's meters because it's distance. But now the next thing is to check my answer. Does it have the right number of significant figures? You look at your things that you were using to calculate. We call it raw data, okay? The things we were calculating with. Look at the number of SF. 6.5 obviously has 2 SF, okay? The problem is 0. We'll talk about 0. But there is no 0, so 6 and 5 are obviously always significant. So 6.5 is obviously 2 significant figures. Okay, and this 130, we won't use it. Okay, but this one, it is 2 as well. So anyway, we would say 6.5 is 2. So that means my answer, and it's the least. So that means my answer should have 2 significant figures. Okay, my answer should have 2 significant figures. I'm going to look here at the third one, because when you're rounding off to 2 significant figures. Now, to round off, if you're rounding off to 2 significant figures, you are going to look at significant figure number 3 before you throw it away, and you see if it is a 5 and above. If it is a 5 and above, then that means you're going to add 1 to here before you throw it away. But it is not. So this would just be 420, okay, meters. You throw away the rest. So this becomes 420 meters. This is going to be my distance. You understand? And I get my 2 marks. How easy is this? Okay, so we'll do the next question in the next video. Goodbye for now.